Hello everyone, in this video I'm going to solve this question that is combination sum. So let's read the statement. Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. Okay, you may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. So if we have, for example, this combination, and also we have this combination, this is practically the same combination, okay, because these two combinations are unique if the frequency of at least one of the chosen numbers is different. And from here we have, in this combination, the frequency of 1 we have 2, and the frequency for 2 we have 1, and the same for this, the frequency for 1 is 2 and the frequency for 2 is 1. Okay, so this are the same. Okay, so here we can have, for example, this is different because the frequency is different. Okay, the frequency for this and this is different. Okay, so the test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. Okay, and we have here some examples. So for this example, we have this array candidates and this target. Okay, and with this combination we can sum up this target. Okay, because 2 plus 3 is 7, and the other valid combination is just 7. Okay, so for this example we have just these two valid combinations, and from this we have these 3, and for this we cannot do a valid combination. Okay, and this is the length of the candidates array, the values for the candidates, all elements of candidates are distinct. This is a very good point, and the target is 40. Okay, so this is an easy question. We are going to solve this question with the take and not take technique. Okay, to solve this question we are going to use take and not take technique. Okay, and also we are going to with just this step we can solve this question. This is a really easy question. Okay, so we are going to take the same number as many times we can. Okay, and when we reach a sum that is greater, we are going to pass to the next element. Okay, so this is basically the only thing that we need to solve this question. Okay, so here I'm going to declare my vector ans. Okay, also I'm going to declare another vector that is going to be my solution, and I think this all. I'm going to create a void function. Okay, and I'm going to pass candidates. I'm going to pass the target. I'm going to pass also my vector ans. Okay, and I'm going to pass the vector solution. Okay, all this vector I'm going to pass it by reference. Okay, to avoid make a copy in each call. And what is going to be our base case. Okay, our base case is going to be when n is equals to index. Okay, or index is equals to n. And what is n? N is the size of candidates, okay? So here, and we have, this is one base case, okay? And we have another base case where our target is less than 0. No, I'm not going to do this. I'm not going to do this, okay? This condition. I'm going to have just one condition. Here I'm going to declare my n, that is going to be candidate size. And here I'm going to ask if index is equals to n. That means that we reach the end of the array, the end of the array, okay? And here I'm going to ask if my target is equals to 0, okay? Because we are going to decrease target with each element, okay? For example, for this target we have 7, okay? And we're going to take the first element. So I'm going to subtract 2 from 7, okay? And for the next call I'm going to have 5, and so on to reach n, to reach 0, sorry, okay? So if target is equal to 0, that means that we have a valid solution, okay? I'm going to push back solution to my answer, and whatever this is valid or not, I'm going to return here, okay? So here I'm going to ask, okay? Here I'm going to ask if my target, now if my current nums, if my current candidate, okay, if my current candidate in index is less than equals to my target, that means that I can't take this number, okay? So I'm going to just take candidates if my target is greater than equals to the current candidate, okay? So here I'm going to push back to my solution this candidate, okay? Candidate in index, and I'm going to call the next recursion, okay? I'm going to call it. So I'm going to pass candidates, okay? I'm going to pass candidate. I'm going to decrease target with this current candidate, okay? I'm going to pass ans, and I'm going to pass sol. But here I'm missing something. I need to declare my index, okay? So here I'm going to pass my current index. Why my index and why not the next index? Because I'm going to try all the numbers, all the same number as I can, okay? If I reach some point of my recursion that I cannot take this number, this candidate, I'm going to pass to the next, okay? This is the technique, take or not take, okay? And when I finish this, I'm going to pop back this candidate, okay? The last candidate, okay? I'm going to pop back the last element. So this is my first call, that is take, and I'm going to do the next call that is not take, okay? For the next call, I'm just going to pass candidates. I'm going to pass the same target. I'm going to pass ans, I'm going to pass sol, and I'm going to increase the index here. Okay, I'm going to increase the index here. And basically this is all. This is all for this question. This is okay, this is the technique, take or not take. This is the take, and this is the not take. So let's run the code if this is work. Okay, first let's call the function, and it's going to pass the parameters. I'm going to pass candidates, I'm going to pass target, I'm going to pass ans, I'm going to pass solution, and I'm going to pass the index 0. Okay, and after that I'm going to return my ans, because in my ans I'm going to store all the valid solutions. Okay, so let's run the code. And yeah, you can see we pass all the base test cases. Let's submit the code if this code can pass all the base cases for this question, because this is just the example base cases. So let's submit the code. And we have a very good solution. Okay, we beat the 100%. We have a 0 milliseconds, and we have very good memory. Okay, this is a very good code. So this is all for this question. As you can see, to solve this combination sum, we just need to take and not take technique. Okay, and what is the time complexity for this question? The time and space complexity, I'm not really sure, but I'm going to call it all the valid combinations. Okay, combinations. If someone of you guys know the exactly time and space complexity, please put it down, put it into the comment sections. And I hope you enjoyed this video. See you in the next.